timer. I'll try not to be the first one getting us too much off schedule. But I mean, saying hallucinations, I'm not necessarily saying they're a good or bad thing, but wanted to just spend a little bit of time just kind of looking at like why hallucinations happen and just kind of go through that. As Justin mentioned, I do have a longer meetup, so the February 6th, I'll be giving a little bit longer speak, kind of talking about the core parts of models, talk about retrieval augmentation, some of the nuances there, as well as kind of agents. I think we're a software development shop. We're in the Twin Cities. We do app dev, data, and artificial intelligence. We have been looking at this AI space for some time. I feel like somewhat of a dinosaur, like thinking about like in 2023, we were working with ChatGPT 3.5, which had a context window of like 3,500 tokens. Like most of the open source models probably had like 400 to 500, but just really thinking about like how some of the challenges with your large language models have been addressed over the last 2 to 3 years. So I think 2023, I kind of like my memes. 2023 felt like every company on the planet was basically saying they're an AI startup, but a lot of the ChatGPT was behind the scene. I think we just got out of the year that like everything was Copilot. So Microsoft, I think, did a really effective job marketing the space, but there are 2025 different Copilots, not sure what to do. And I think generally, a lot of people believe 2025 is really going to be the year of agents, the year of reasoning. That's really where a lot of the models are. And ideally, it starts becoming, we begin to see more and more acceleration in the way that people are kind of using some of these things. So again, I think some of it is like, we've been following this trend, like, a lot of 2023 was chat-based. I think we've been doing a lot of work with clients in the retrieval space. And then, especially over the last, 6 to 9 months, we've been spending a lot more time on the agentic side. And, as part of that journey, I think really understanding like hallucinations is obviously one of those big kind of boogie women as part of, or boogie, whatever, however you want to define that. And it's not necessarily a good or bad thing. So I kind of did a preview of this talk to some of our folks internally yesterday, and they were saying like, you're trying to say, hey, hallucinations are a good thing. But I don't, it's really a behavioral part of like how a lot of your large language models, they are probabilistic models. You're not necessarily going to get the same results. That's a good and bad thing. And as developers, as builders of systems, we feel it's really, really critical for you to understand why that happens and what are the root causes of that, so you can either build around it and or you can actually leverage it, which, one of the examples I'll talk about, especially in the chemistry space, it has actually been a huge boon for what they're doing. So spend a little bit of time. Now again, I don't know how technical people, get, but like, transform models, I think is fundamental, a big part of like why we are where we're at from large language models. I think the attention mechanism, if you're aware of what that is a really critical part of that. And that really feeds into why most people believe large language models hallucinate. And then kind of just talking about hallucinations. So I think, and again, I apologize if the slides are a little bit too small for people in the back. Feel free to ping me if you're interested in them. But fundamentally, I think kind of why we're where we're at. There's been these kind of 3 really critical dimensions on kind of scaling in the AI space over the last 50, 60 years. The models, the data, and compute. And we've seen kind of various different speeds in which they've kind of evolved. And I think really we just had this like intersection of all of these in November of 2022 when ChatGPT got released. And I think that kind of has led us to this strong adoption, this fascination with what these large language models can do. So obviously, from a data standpoint, I think the availability that's been really critical. You can look at NVIDIA's stock price has been a huge factor in the ability to both scale up a lot of your compute and really being able to kind of scale out primarily your training. And you're seeing a lot more like kind of inference time or test time kind of stuff down. And then really the models. And I'll focus a little bit more on the models because I think fundamentally a lot of your hallucinatory behavior is really driven by how some of these models operate. And that's really wanted to spend a little bit more time on. Now, my next talk will probably talk a little bit more about like some of the reinforcement learning, how do you actually build some of these models. I think there's a lot of really interesting things happening in the reasoning space and how do you build these models the same or different because you have these O1, O3, deep sea kind of models out there. But fundamentally, I think we're always really thinking about how do these 3 dimensions kind of come together and how do you go build systems around that. So won't spend it, so this one. So like jumping into, I'm just skipping this one. I'm assuming everyone knows about neural networks. So I'm assuming a lot of people are aware, attention is all you need was a paper that Google, a team of researchers at Google wrote, came out in June 2017. And it's really, I think, put us in the position where we're at. So I don't necessarily know if you really need to understand a lot about what the transformer specific kind of internals are, But really, number one is it really drove a huge amount of innovation in the space of these new models. So this new architecture, I think, really was a fundamental game changer in the way of dealing with natural language and really being able to kind of provide a more compelling experience, something closer to like a Turing test. So having an experience where it's actually like you're talking to an individual as opposed to a technical person or like a machine. And I think specifically the attention mechanism, it's really a way of kind of, basically what it did was like kind of figure out how do you correlate kind of the context more broadly within a sentence. So I like this example on the right-hand side, if you're able to see it, there's 2 words of interest, and really depending on the context of that word within the sentence, it has very different meanings. So like no interest is kind of more of one meaning. Interest rate, then you can kind of associate it with the percentage. So I think the attention mechanism really added to these, these large, deep neural networks that existed previous to June 2017, and really provided this notion of how do I analyze my words? How do I try to do a much better job predicting what the next word would be? And that's kind of really that attention mechanism. So the attention mechanism really, I think, is really fundamental to understanding why these large language models are able to do kind of what they're able to do. And as part of that, I think the model temperature is a really critical part of that. So this top chart kind of shows, here's kind of a chart of like, here's kind of the probability of next word. And really, as you're kind of cranking up and down the temperature, you're basically being able to kind of determine like what is the most likely next word in your sequence. And that really is, I think, fundamental to why a lot of people believe these large language models hallucinate quite a bit, because you're fundamentally really playing around with the temperature, and like if you crank it up or down, you're getting more like less likely words. Now, like from a perspective, if you're really doing something deterministic, if you're doing like a RAG model or something like that, or if you want something more creative, this is kind of this spectrum that you can kind of do. So it's really, in many ways, it's fundamentally behavior of how transformers work, and that's kind of a big part of that. So I have too much material, so I'm gonna go through a few things. I'll jump, maybe just like, just jumping through, hallucination. So I mean, I think, people have, if you kind of pay attention to like the, I guess in YouTube. So like there was a Nobel Prize in chemistry that was won last year, and it was fundamentally around, I included some like quotes, like these are like some of the names of articles. Like, so there's, I can probably read here. Like, so, integrating cross-modality, hallucinated MRI. So they're actually using this hallucination behavior in your images to actually improve the results. And this is, they're not hiding from it, right? It's like, this is an article in Science. The next one is, I think, one of the more foundational ones. Like they leverage these deep networks to and the hallucinatory behavior to be able to explore like kind of the protein space kind of more effectively. So all to say is, obviously, if you're doing something that requires a lot more, if you're doing something in the legal space and financial services, you don't necessarily want hallucinations. But if you think about some of these creative spaces, if you think about these spaces where you're actually trying to explore a much larger landscape, it actually is a really powerful part of that. Just wanted to end with my 40 seconds left, but I wanted to kind of give an example of a client. So we built a pretty simple RAG chatbot. They have a website, they have a bunch of content, and we're getting this really weird feedback where people are saying, and we provide links. So it's like, hey, I have a, it's actually for a client that does like learning and thinking differences or a nonprofit. And like we give back links, so they have a lot of really good links about ADHD, autism, different things. And at some point during these interactions, they start seeing hallucinate. Hey, these links don't work. And we were like really puzzled because we'd done a huge amount of like kind of expert evaluation. We've done a lot of automated testing, and we had not really thought about like the history. So as like, like most of the interactions, like if you had like 10, 20, 30, 50 interactions with the chatbot, the thing started hallucinating, or it started kind of interpreting like URLs in a very different way. And it was just something that we had not intuitively thought of. But my time's out. Yeah. But this is an example of, I think, where hallucinations, it's a good and bad thing, and really understanding it